Hallo Leute und willkommen bei der Panzer. Okay, folks, we're back to your long-awaited Panzer update. When we last saw you on this project, I had the rear drive unit taken out and we had removed, where's it gone? Get the props out. I had removed my old V2 logic board from the drive unit, and we had installed a new V6 unit that Johannes gave me, and we tested it here on the floor. I'd made a video about some of the aspects of how to safely test the drive unit and so on. Now, since then, the drive unit is now back in. We've got drive shafts in. The whole rear end is reassembled, basically. And we have new cables running up both from the boot with the charger and fast charging and all that stuff in there, up to the front of the vehicle with some of my nice 3D printed clips. So that's all neatened up. I've stone chipped, cleaned up all the rear end while I had the drive unit out, got rid of any rust I was trying to set up shop, primed it, stone chipped it, made all of that kind of nice before putting the drive unit back in there. Up the front, we completed the rewiring of the burnt loom. I have also now brought all of the wires that I'll need for the VCU up to the e-box. I'll show you that. I got a new e-box to go in there because some genius, mentioning no names, had decided to remove the actual e-box compartment from that car when I was doing the original conversion on it. But I was lucky, found a guy breaking one in the UK. I managed to get that sent over. So if our e-box in there now, so our Zombie Verter VCU will have a nice place to live. Yes, we will be controlling the drive unit via CAN, but we do have a hardwired brake signal also going back to the drive unit as well as the CAN signal. Whereas our VCU will be looking after the contactors and all of that kind of thing in our battery, which we have been progressing on quite a bit as well. Also been sorting out the heating cooling, so I'll show you that now as well. Radiator mounting and stuff like that I'm going to try and figure out. I'm probably spending a lot more time on parts of this now than I would have normally or than I did in the past, because I'm trying to do it a little bit better. I guess I'm all, I should be trying to get better at this, right? Not always the case with me, but I should be trying to get better, and, this is my attempt at trying to get better. So let's go have a look at the vehicle, and then I'll wrap up anything that we have to comment on after that. Okay, so here on the bench we have what you might say I've gone a bit nuts with the old 3D printing and the free CADing. So we got an aluminium plate. This is some 6mm aluminium. I got some aluminium given to me from one of the jobs I did, and it's, well, I've been using it quite a bit here. So I've designed a bracket for this, it's not a Volvo, Bosch Volkswagen coolant pump. So this is going to be our heating system pump, so for heating the passenger cabin. So the supply comes in here, pumps into the Volkswagen. This is a Lin controlled heater. I think it's 6 kilowatts or 5 kilowatts or something like that. So I'll have some Zombie Verter firmware to be done for that guy. And then that splits the 19mm output into two 16mm pipes. because of course our Panzer has dual zone climate control. This big BMW pump then was a bit of a nightmare because all the brackets that were on this were just not in the right space for me to clock the pipes where I needed them to be. And unfortunately, yes, you can take this front part off, but you can't clock it because there's stator vanes in here that will only fit in one way. So obviously we're going to have our cooling water coming in here up through this. It's 35mm pipe. I machined an aluminium adapter here then to take me down to 19mm. That'll feed back to the drive unit, and then the water will come back up. Well, the drive unit and the charger. And of course then I had to design and print this flipping bracket thing. So this mounts basically underneath the vehicle on the original gearbox mounts, so up the front kind of area where the bell housing and stuff like that would have been. So it kind of what's the word for it, uses that space that we weren't able to use previously. There's a bit of sun out here now, so I'm going to run around the back of the car. I've stripped out, let me get my shadow out here way. I've stripped out the old JLD 505 and all of that nonsense there for the CHAdeMO. So we have our contactors for our CHAdeMO in here, but obviously all the CAN and the control of that now will be done via the zombie verter. So we don't need any of that junk that was in there now. So I'm going to retain the CHAdeMO fast charging. Tesla Gen 2 10 kilowatt onboard charger and our HV junction box. As you can see, still working on the wiring here. I want to tidy this up. It's a real mess job. I want to try to do better on that. Let me get out of the light. And obviously in there then with our Gen 2 Tesla DC and so on. So I got to try to loom this out a little bit better. So that's kind of the back end. I'm debating whether I'm going to redesign that Gen 2 charger logic board to have a dual CAN channel on it. So I'm kind of hemming and hawing on that one. I do want to get this car done, so you know, but again, I'm fighting myself here. I want to get the car done, but I want to do it better, do it right, so on and so forth. So yeah, that's there. I'll get to the battery now in a minute. That's be quite in depth. Oh, I was also given this thing, which is quite neat. I've never had a TIG welder before. So yeah, I've got a TIG welder, but I don't have a TIG torch. So got to try and find some kind of a fitting for this, for my big TIG torch. Excuse me, that I have in there. It's a Sherman brand, never heard of it, but I've used it for some arc welding there on the battery, and it's super smooth. So yeah, nice thing to get. Over here, engine compartment, you're not going to see a lot here. There's not much going on. I have my little Honda Civic radiator here that I'm kind of working out how that's gonna fit in for me. And over here then I have all of my wires coming up. This is my new, well, you know, replacement e-box in here. So I'll be making my zombie verter loom now. I have my grey one is coming from the drive unit, and the black one is coming from the rear boot area there, which we just saw. Because we'll have the rad here for the main cooling system, I'll be able to use this bottle that I'd mounted here for the heating system, so I won't need to be mounting any more bits there. So, oh, I also got a label printer that can do those. I don't know where it's gone. I'll show you in a few minutes. I got a label printer that can do these heat shrink labels, and I gotta say, really neat. So I'll show you that before we wrap up, because I got to, you know, obviously have all these little bits of tape here. It's not the best. So that, yeah, I'm going to neaten that up. Obviously, our, you know, the VCU will be going in here and so on, and that'll be, you know, a lot neater. But we've all our wiring repair, loom repair done, and all the 12-volt systems and everything else in the car works normally again now. So, yeah, still think that was such a narrow escape, that fire. So, okay, let's, speaking of fires, let's go have a look at our battery, and we'll kind of talk you through what I've been doing here with this replacement battery and what it actually is and so on. Okay, so our plate is now back in. So the next thing we want to do is to fit these to kind of, let's call them, I don't know what I want to call them, battery tie downs, support brackets, whatever we want to name them. They go in here like this. Now their mission is kind of twofold. First thing they do is to stop our batteries from moving, and the second thing they do be providing 4 lifting points for the whole pack when it comes time to lift it as a whole pack back into the Panzer. So first of all, what do we actually have here in terms of our battery? Well, what we have here is actually not one, but 2 Gen 2 12 kilowatt hour BMW 530e hybrid battery packs. A total of 12 modules, 4 modules per, I call these blades. 2 modules and 2 are basically sandwiched against some 12mm aluminium plates, and those plates then slide down through these guides on the side here and on the bottom that basically center them up. Obviously MIG welded. Now these guys here then bolt in through the side with 10mm bolts, and strengthener plates will be going in on the outside here just to give us maximum mechanical strength here when we're doing our lift. So connecting the battery to the outside world, we have a high current and a low current high voltage connector that I purchased from Tom DeBree's shop. I'll put a link in the description to that. I've got the matching plugs and pins and all that stuff then to connect on here. And on the side here you can't really see it, but there's a 14-way amp seal connector which will be doing our CAN bus and various other low voltage connections from our insides of our battery pack out to the outside world. So normally I don't use these kind of things. I kind of consider them a waste of money. But in this application here, I want the battery to be kind of easily removable, because this battery might end up in different vehicles, might end up getting upgraded. Don't really know, and it's just a new thing for me to experiment with anyway, and it'll make connecting this up a lot easier. But more importantly than any of that, it means I can get everything here built outside the car. I can test it, I can mess about with it, and then when I'm sure I've got all the sillies and the bugs out of it, lift it into the car and have a reasonable confidence that when I do connect it up, it's just going to work. So what else are we doing with our aluminium, or not aluminium tub, stainless? It's 1.5mm stainless steel box that I had professionally made up, because I wouldn't be able to make that. So it's guillotine cut TIG welded stainless. Now the other thing I haven't fitted yet, but we're going to be putting on is this guy here. Now it's various names. I call these a blowout disc. It's probably the wrong name for it. This will be going on either the front lower part or the bottom side of the battery. And its purpose is to basically relieve pressure inside the battery casing in the event that we have a fire or some kind of something that's creating hot gases or cell failures or anything nasty in there that's trying to build up pressure that could turn this casing into a bit of a rupture situation. This guy here will avoid that and direct any of that smoke and hot gases and stuff, just give it some place to go. So that's what that guy will be doing. Now, in terms of how we're going to monitor our battery here, as I mentioned in the description of the plate, I won't be using the ISA shunt to do the kind of midpoint monitoring on this, because we have on our battery, these particular modules come with their own BMS slave, and they transmit information about cell voltages and so forth via CAN bus. So what we'll be doing is here quite simply bringing our 2-pack BMS CAN bus, and I think they need a 5-volt enable or something like that, out here to our amp seal connector, and we'll be able to write a module for our Zombieverter VCU then that will communicate with the BMW BMS and keep an eye on things there for us. So that's where we're going to be with our battery. So we'll have the 2 parallel packs, nominally about 24 kilowatt hours, all inside this stainless steel enclosure that it'll be mounted on 4 bolts. There's we can't really see it too well, but there's a piece of 100 by 100 stainless box section welded to the center bottom here. That mounts on the original engine mountings, and then up the front there's 2 more mountings that go up to what I think would have been originally the radiator cradle. And this part of the box here sits kind of up, so that it'll be sloping towards the front of the vehicle. You'll see this better when it's actually mounted in there. So that is our battery for the Panzer, and our connection system there for it. So I have the actual leads made up, so the only last bit of metal work that I have to do on this, or last bits of metal work, will be fitting the blowout disc and then putting the lid on and locating where I'm going to put mounting hardware basically for the lid. Right, so I don't think that's about it. It's not, you know, it's not particularly complex. It's just a lot of different bits that need to be pulled together to make that happen. All right, let's see how much of a fool of myself that I can make here now with this. So what we have is our plate is in here, slid down here, and I've another one of my famous FreeCAD designs, these little mounting blocks for the plate. So this one mounts in the top here and basically keeps the plate from jumping up. But there's two more on each side that should let it slide up theoretically. So let's see if the theory meets the practice. So I haven't tried this before. Oh, something's happening. Oh, wow. Okay, let's not break anything. Oh, I'll be damned. It actually worked. Okay, let's let's turn it this way so you'll be able to see it, and I will get something to kind of point through the various components for you. So the board itself I have here is an interesting material I'd never came across before. It's a honeycomb of some kind of plastic or something sandwiched between two aluminium sheets. So it's only 4 millimeters thick, and it's quite light, but it's also very strong. So I was quite happy to have found that, and it worked out here for me in a kind of a way to mount all of my bits on. So we'll start here at the left hand side, and what we have are our two negative side contactors. So each of our separate battery negatives will connect here to an individual contactor. They're then brought together on this aluminium plate, 6 mil thick, brought into our 1000 amp ISA shunt, and then this will be the main negative terminal which will connect to the output socket on our battery here. I'm using these kind of standoff insulators, but in this case they weren't tall enough for what I needed to do, so I just 3D printed a little spacer. It's just a cylinder with a 8 millimeter hole through the middle, just to bring them to the right height. Similarly over here, what we have are our positive battery connections. We go through two 350 amp fuses for our two main contactors. Again, 6 mil aluminium plate, bringing them together. This is our main positive terminal here that goes to our battery output. Finally, over on this part here, we have our pre-charge contactor and pre-charge resistor. Over here then, I have two pole, 32 amp, 1000 volt DC solar circuit breakers that I'll be using for my low current high voltage output on the smaller connector that we saw on the front of our box here. So quite simple, but hopefully does the trick for us. Our ISA shunt has got 3 voltage measurements. So what we'll be doing is, obviously we'll be using our V1 to measure the output voltage here to know when our pre-charge is either working or not. But rather than using the other two to measure the kind of 1/3 points of the pack, which would be kind of useless here in a way, as we have the BMSs on these modules anyway, we'll be using the two spares here to monitor the HVs, here on this side of the main contactor, because our power up sequence will be something like this. We're going to close the negative sides. We're going to check that we have our two packs available here on these contactors, the pack positive. So for example, let's say if we'd one pack that had mysteriously failed or something, or had a bad cell or a couple of bad cells, then there'd be a big difference between the voltage we'd see from pack 1 and the voltage we'd see from pack 2, and we can abort startup, because what we don't want to do is to accidentally feed, like say if pack 2 had a fault, we don't want to feed the power from pack 1 then back down around this path back into pack 2 and cause a problem. So obviously then, assuming all is good here, we can then engage pre-charge, see our voltage come up here and close our two mains and drive down the road. So this will be all controlled by the Zombieverter VCU, as I say. So there'll be some extra modules and so on for this methodology of twin pack controlling, and obviously our BMW hybrid BMS slave module thingamybobs. So I think I've bored you all now, hopefully to the point where you've tuned out, and that's our battery. So I have been, working away on it. I haven't been standing still. So fingers crossed now, we'll get this guy wired up, get him in fairly soon, and we can start turning some wheels for the Panzer again. All right, folks, so we have kind of looked at the Panzer and what I've been doing so far. And so just to kind of wrap up a little bit on that, project I've been working on in the UK, working with, I've been assisting a little bit on in the UK over the past few years, will be made public fairly soon now, within the next days, weeks kind of thing. And there have been some very impressive power figures coming out of the Model S large rear drive unit, obviously with the open inverter control, the same as what we're doing here. Now the car that's been used there is, much better traction and LSDs and drive shafts and all that. I won't be seeing any figures like that, but by the same token, I think you'll be impressed when that becomes public. And probably even more impressive is what's powering it, which is not two, as we have in our battery box here, but just one BMW 530e hybrid pack. And the ability of those packs to put out power again and again and again and again, and not have any thermal problems that have been, people just like talking themselves into a tizzy about, because I know that's going to come up again now with the battery, and this is all factual. There's no makey up. There'll be figures published, raw data published on this too, if you need to see it. It's not BS. I've seen it, others have seen it, and it's repeatable over several different packs. So that'll be coming soon, and I will be hopefully getting myself in gear and getting the Panzer turning wheels soon, and getting her out back on the road where she belongs, and getting the Red Arrow in for the winter, keep me company. So, not that I'm fed up with the Panzer, but I just want to drive the Panzer again. Anyway, folks, I'll leave it there. I'll probably bored you all to death again. Sorry. So this is why you shouldn't support me, you see, financially or anything like that on Patreon or PayPal or any of those stupid links in the description. Don't do it. So in that case, we will see you in the next semi-exciting episode, hopefully when we have something more substantial like turning wheels in the Panzer. And until then, happy battery building.